Yes, dear lovely viewer, very good evening. I take this chance to welcome you to today's session. First and foremost, my name is Super Isaac, and my today presentation is about fundamentals of artificial intelligence, and I will be relating it to my project I'm currently working on, that is LiveGuard project. Briefly, LiveGuard is an AI-powered chatbot for detecting crop pests and diseases. So without wasting much time, let me go straight into the details of today's presentation. Here in our first module, we have history, trend, and future of artificial intelligence. In the research I conducted of recent, I realized that AI didn't just appear from the blue, but rather it has some of its root in old ideas that centered on building machines that could think. And the brain behind this discovery were Leonardo da Vinci and Alan Turing. Well, Leonardo da Vinci model a mechanical system that thinks like a human being. And Alan Turing is also known for his famous test, that is imitation of human thinking. That was in 1950. And quite over time, this artificial intelligence kept on moving, where in 1970s there was discovery of expert system, and in 1990s machine learning came into play, and in 2010 deep learning was also discovered and is still in use up to date. So for this discovery, show how data mining evolved from basic rule system to complex predictive modules. And philosophically, this highlights weak AI, that is machine stimulating reasoning without consciousness. In context to the project I'm working on, that is LiveGuard, it also reflects the same journey as artificial intelligence, that instead of using old school rule-based approaches, we apply machine learning to real farm problems, where system analyzes leaf images and detect early sign of pests and diseases. Greatly, by so doing this, it showed the progress in artificial intelligence translating directly into agriculture. And knowledge intelligence realized in this was naturalistic, that is learning from the pattern in nature. Moving forward to the second module, that is problem solving. Here we have that AI start by defining a problem before solving it. And it has three areas. Firstly, we have initial state. That one represent the current situation of a problem at hand. We have operator, the step which are employed to overcome the problems. And lastly, we have the goal, that is the achievement at the end of solving the problem. Now I will give you a scenario of a puzzle where the scribble tiles are the states, movement are the operations being employed, and solving the puzzle is the goal. This reflects logical mathematical intelligence, that is planning the algorithms. And the philosophy reminds us that knowledge what details to include when solving the problem is never trivial. Now relating to the leaf guard, the project, the initial stage is simply the crop leaf captured by camera. Then for operators are the algorithm that processes and analyzes the features. Meanwhile, the goal is to correctly label the leaf as either healthy or disease. Our third model talks about problem solving by search. When AI looks for a solution, it doesn't just guess it randomly, but rather it uses some search methods. Like here, when I was learning fundamental of artificial intelligence on Allison, I realized there is breed first search, which check for everything. And another one was also a star. This one uses a shortcut that guide the search toward the promising options. And heuristic resemble more of a practical intelligence, guiding search like a farmer institution. And in philosophy, this balances the exploration and exploitation. Then next is relating in our LeafGuard AI chart. For it uses heuristic search in a way that instead of a farmer wasting time testing all the possible diseases, the system will only focus with the most likely affected. And this helps in saving time since it gives a faster and most accurate results in shortest time possible. Next is knowledge representation and reasoning. We know AI is not all about data, but rather it's about representing knowledge in a way that computer can use. Aware that computer or the machine uses rules and logic that are programmed in them. Taking for instance, when I have some of the variables, here I have my P, Q, and R. And I have some of the propositional logic, the connectives of and or implication, then by conditional. We know and meaning the boss operand or the boss condition should be true, or either one of the condition is true. Taking for instance, I have this statement here that if leaf shows yellow spot, then suspect infection. Let's say my first statement here, the assumption is represented by P, then the conclusion is Q. So in moment I realize an infection, definitely I conclude that there was yellow leaf or yellow spot. And intelligence being used under this one is linguistic intelligence, that is expressing the rules. And also there is intrapersonal intelligence, that is self-reflection. So meaning the system keep on reflecting on what it has been fed in before. So in our AI power chatbot, that is LeafGuard, for it encoded the rules. Like here, if I have moisture which is less than the required threshold and the lesions are present, then I classify as fungal diseases. So these symbolic rules add domain knowledge on top of the machine learning. thus giving us a stronger and more reliable predictions. On another module, we have inference in fast logic order and reasoning under uncertainties. Well, here I came to know that AI does not stop at storing rules only, but rather uses inference to draw new conclusions. And to stay on track, it keep on processing both the soundness and completeness. Soundness is all about producing the truth. Meanwhile, completeness is not excluding any truth. And to cater for the uncertainties, it incorporated probabilistic reasoning. One of it is Bayesian networks. And the intelligence being used here includes logical mathematical intelligence, that is generating the truth at the end of the process, and naturalistic intelligence, that is learning from pattern in nature. And our LeafGuard uses Bayesian reasoning, where it combines the logic with probability. For example, if the lesson is circular and brown, we conclude that the bacterial spot stand at 75% confidence, meaning that even when the sign collapses, LeafGuard can still guide farmers toward the most likely diseases. Stretching to another module, that is planning and decision making. So here, an AI has to first plan before it detects a problem in such a way that it can figure out the best action to take. Because planning helps in laying out the steps, and decision making weighs the resources being used, the risk, and the benefit. And during the course of study, I realized some of the tools being used for this planning and decision making. One of them is Markos decision process, which helps AI make the smart choices under uncertainties. And during planning, the intelligence being used are interpersonal and intrapersonal. Let's see how our LeafGuard utilizes this action planning. So here, once a system detects a disease, it will suggest the best course of action and perhaps even recommend the best fungicide or even irrigation changes and pruning. Importantly, it considers the resources. For example, may choose pruning over pesticide if the cost of pesticide is a factor. On our last module, that is machine learning in artificial intelligence. As I highlighted earlier on, that machine learning is the backbone of modern artificial intelligence. Here we are only centering on the types of machine learning, and there are around three. There is supervised learning, unsupervised learning, reinforcement learning. Wherein supervised learning, it's learning which is centered on level data. Like in case of our LeafGuard, is categories of the disease being identified. Then unsupervised learning is finding from hidden pattern without levels. Meanwhile, reinforcement learning is learning through trial and error method after obtaining the feedback. And here we have two intelligence types, that is logical, mathematical, and naturalistic. And here in philosophy, this one helps in reinforcing the weak A high, like the task-specific smart system. And in our project of LeafGuard, it uses supervised learning, where we train a system on 1,000 of level leaf images. It learns these images, classify new one as healthy fungal infection or bacterial infection. And the more you feed in data, the more smarter and more accurate our system becomes. All right, let's see some of the impact or benefits of using this LeafGuard. First of all, it helps in early detections of diseases, thus saving crop from being affected. And it also reduces on pesticide cost. So here, LeafGuard shows how classroom AI concept can solve real Uganda agricultural challenges, which are directly impacting the farmer's life. In conclusion, these LeafGuards give us a blueprint of all the modules we covered right from the very beginning of history, trend, and future of artificial intelligence. We went to problem solving by search, knowledge representation and reasoning, and the uncertainties. There was planning and decision making. And later on, we had machine learning. So it encompasses all this module into a practical solution, which help to protect crop against pests and diseases. So this brings us to the end of today's presentation. And our motto stands, healthy leaf, stronger harvest. Thank you for watching. Have a lovely day.